Okay, so welcome back, everyone. So now we are going to focus on portfolio choices. So again, we are still on under utilities, right? So anyway, arbitrage. So okay, before we can start with again, before we can start with before we can start with this section, do you guys know that maximizing your utility, actually minimizing risk, is the same as maximizing your quadratic utility, right? So they have shown this proof in your notes, so I'm not sure if any of you want to show want me to explain the proof, but I don't. So do you guys want that proof where it explained that maximizing again, minimizing risk is the same as maximizing your quadratic utility, or should I get into this section? Okay, everyone else, are they fine? Maybe because I don't think it's that complicated. It's just that it can be confusing sometimes. So I think you guys are fine. Okay, no problem. So I'm gonna start straight to on arbitrage and the price and price of one. Again, law of one price. I'm not gonna explain much about arbitrage. So basically in this section, what we are doing it because we are trying to find whether there is no arbitrage or not, and if there is an arbitrage opportunity, will we be able to take advantage of it? Since we have skipped cap M and factor models, so we did not really explain much on so we did not really learn much about arbitrage. So yeah, so in this section they explain that there are two types of so there are two types of arbitrage, A and B, where in layman terms, type 1, type A, is when you receive something immediately without having to pay anything back. And then type 2, type B, is when you have a probability of yielding a positive return without having the probability of yielding a negative return at no cost to you. So these two types of arbitrage, we assume they should not happen, but then if they do happen, then you can exploit them. So what we are going to do in this section, we are going to do questions that will try that will try to find the price that that does not have an that does not have an price that does not have an arbitrage opportunity. So anyway, so first of all, we start with the theorem. So this theorem says that we are going to use our utility function to construct a portfolio which gives us a maximum satisfaction for our wealth. So you can only be satisfied based on how much wealth you have, right? So if you want to make an investment, you can make an investment that does not exceed your wealth, because you want to have money to pay for the other things, right? So and then you are trying to maximize your satisfaction, you are trying to maximize that. So you are trying to maximize your utility, right? you are trying to maximize your utility function in terms of payout, right? So again, the future, like the prices or the state payout or future payouts, they are not known. Therefore, you are not trying to maximize only utility. You are actually trying to maximize your expected utility. And then you also have a constraint. Your constraint is gonna be what? Your constraint is gonna be your wealth. So the amount of shares that you buy are going to be less or equals to your wealth. So before I can do this proof and do examples, I want to explain this components first. So P I is the price, right? Is the price of security I, and then let's say DI again is the payout, is the payoff of security I, and then theta I is the amount of security I that you are going to buy, right? So before I continue, this payout, right? So in this payout, so the payout include dividend of your security as well as the price, right? So let's say maybe your asset is time 0. Your asset cost 10 rand, and then in the future at time 2 is gonna cost 12 rand, and it will also have a dividend payout of 0.5 cent, right? So it simply means that your D is gonna be 12.5. So this is what they mean by payout in this section. So they are not looking at rate of return, they are looking at the payout in total. So this is going to be your wealth. It's going to be the wealth. It's going to be your wealth. Well, you can say wealth of an investor. And then you have X. X is your state payout. You can say state payoffs. You can say payoff, payout. So it's fine. So anyway, to explain more on state payoffs, if we are in a world that have two states, right? So let's say maybe you have state 1 and state 2. So state 1 is when the economy is good, or here is when the economy is bad, right? So let's say the price again is 10 rand, and then your payout is gonna be how much? Let's say maybe it's gonna be 12.50, and then here your payout, let's just say maybe it's gonna be 9 rand, right? So only one state can happen. Like, even though we are considering both of them, only one state can happen in the, so only like at the end of the time. So at time 1, only one state will happen. It's either this will happen or this, but it's never both, and it's not the average of both, because we are looking at discrete because we are looking at discrete states. So again, if let's say this one is security 1, if you have security 2 again, let's say again this one costs like 5 rand. State 1 if it's good, state 2 if it's bad. let's say it's gonna cost like how much? 7, this, and then here 2, right? Again, only one state is gonna happen. Is either this is gonna happen or this, but you will not have something like this or like this. This won't happen because only one state is going to happen. Like it's kind of, so you are either going to have state 1 or state 2. So I'm trying to explain this because when we do the calculations, it can sometimes get confusing to understand both the state pricing or the state payoffs, right? Let's say maybe you have bought 2 asset of A. So I'm like, let's say maybe you have 2. I'm like, you have bought 2 of, again, I'm like, for say security 1, for say security 1 you have bought 2. For security 3 you have bought 4,3 of this asset. I'm like, of this security. So it simply means that your payout, your state payout. So for state 1, let's say maybe for state 1, if you have state 1, then you are going to have the sum of the amount that you have bought times the payout, right? So for state 1, the amount of security 1 is going to be 2, and the payout is going to be 12,5, and you have bought 4,3 for state 2, and then the payout is going to be 7, meaning that the payout under first state is going to be 2 times 12,5, 4,3 times 7. It's going to be 55. It's going to be 55,1, right? And then if state 2 happen, you are going to have, so you have bought 2 of security 1, which pays 9 at state 2, plus you have bought 4,3 times 2. So yeah, basically this is how you calculate your your state payoffs. You cannot have a combination of these two. Only one state can happen, but not both of them, but never both of them. So yes, so before we can go further, we are going back to our formula. I'm like to that equation. You're trying to maximize the expected utility in terms of payoffs, and you have a constraint. So you can make a Lagrange equation. You can say L is going to be equals to this minus lambda, and your and then your constraint is going to be what? It's going to be the sum of all the things you have bought times their price minus your wealth, because you can buy as much as your wealth allows. So the first derivative of L in terms of what? In terms of x? No, not in terms of x. In terms of lambda, I mean theta I equals to 0. So your answer for this is going to be this. So you are going to have the expectation of, and then you use chain rule, right? and then when you differentiate this thing outside, you are going to be left with I minus lambda p I. When you differentiate this in terms of theta, you will be left with pi equals to 0. And then you are going to have another one where you're going to say the derivative of lambda. So this is for all, this is for all i's, for all your assets, for all your security. So the first derivative of lambda of your Lagrange again, and then you will be left with something like this. So you can basically simplify this and say it's equals to 12. So when you so when they ask you to find again, I'm like to maximize your so to find the weight of your portfolio such that you are maximizing, actually when they ask you to find the weight of each security such that you are maximizing your utility, you are basically going to answer these two questions over here. So this is what they are asking you to solve. So this is where they come from actually. So yes, so these two things are the things that you will have to solve to find that question. I'm like to find that answer. So I have a question. So this kind of question can have like 5 or 6 marks. So as you can see, this one has like 5 marks. So we can solve this one together. Question?
Hi, Isabella.
Yes.
I just have a question on the formula.
Yeah.
Because the thing is in the textbook, so that x, right? Which is the x star.
Yeah.
That's the expected utility of final world, isn't it?
His what?
The expected utility of final world. That x star. Yeah.
The expected.
Is that correct?
The expected utility of final wealth.
Yeah. Is that correct?
Expected utility of final wealth.
Because like in the textbook on page 242,
okay,
it says the summation, the constraint,
yeah,
x equal to the summation of theta I times di. So that's what that x is, right? That x
yes,
star.
yes.
So that means those theta i's, which are the amounts of the various securities,
yes,
are they greater than, they obviously can be greater than 1, right?
Yeah, they can be greater than 1.
So then how will x star be an expected utility? Because isn't the expectation of a function supposed to involve probabilities?
How does what?
The expected utility, right?
Yeah.
It involves probabilities.
Yes.
So those thetas are supposed to be less than 1, right?
No, they are not necessarily supposed to be less than 1. They can be greater than 1. Sometimes they can even be greater than 10.
Okay, then why is it called expected utility though? Like that's the part that trips me a bit. Because it's like taking the weighting of the payoffs.
Oh, actually,
expected.
Again, so the states are the one which will have the probabilities. So again, let's say maybe you let's say maybe you have like 2 states, right? So this one, let's say he's gonna be security 1 with price P, right? So let's say maybe here is payout of A and B. Okay, before I can say A and B, let's say the state is gonna be A and B. It's gonna be A and B. So the probability of state A, right, should be less or equals to 1. So does the probability of state B should be less or equals to 1. But then the thetas, they actually measure how many shares of security 1 should you buy. Not necessarily, again, I'm like and not necessarily the proportion, because in this course so far we have only looked at the proportion, but then right now they are no longer looking at the proportion, they are looking at how many shares should you buy. So this theta so this lambdas so these thetas can only be less than 1 when you say that okay, let's say maybe you have DW. Actually, now before I go here, you have the sum of thetas times the price I equals to your wolf, right? So let's say maybe the sum of theta I over weight times pi is going to be equals to 1. Then theta I over W can and should be less or less or equals to 1. But then remember that so far we have only looked at measuring we were only so basically Horn-Markowitz factor model and CAPM, we were basically looking at the proportion you should buy, not necessarily the amount you should buy. That's why this thing is called the amount, it's called the amount and not the proportion. I don't know if that makes sense. Actually,
that sort of makes sense. Is that also the reason why, in that portfolio choice theorem, and they're maximizing the Lagrangian, they have that price is equal to 1? Is that also another reason? Why so the inequality is less than or equal to 1?
Yes. So when your price is gonna be let's say maybe your wealth is gonna be less than 1, or maybe your wealth or maybe if your wealth is gonna be equals to 1, then the amount of shares are also going to be less than 1, given that the prices are also going to be 1 as well.
Okay, that makes sense. Okay. Thank you so much.
No problem. So I think this example here, I'm like, this example can seal the deal. So let D1 denote a risky asset. We have price 1 and pay off B plus 1 for state A. I'm like, okay, let's see, and 0 at state A and B respectively. Each of the state have the same probability, so they have probability of 0.5 and 0.5. Let D2 denote a risk-free security with price of 1 and interest rate of 0 over the time period. Suppose that the utility function is going to be this thing over here is used, and assume that an optimum portfolio X star exists where X star is going to be greater than 0. Suppose that this person's current wealth is going to be equals to 1. So determine the amount to be invested in risky security in the portfolio that maximizes utility. So this question wants you to use these things over here. It's basically asking you to use these things over here. So this is what they are asking from you. So we know that those two functions, I'm going to write them down before we can solve them. We know that we have the expectation of the first derivative of X star di equals to lambda price of I for all i's, and the other one you will have to solve is the sum of all of the weight all this equals to your wealth. So they said find their amount. So they are basically asking you for the thetas, like for the thetas, right? So this is what they are asking you. So I can try to like simplify this. So security 1, which is also called what? Risky asset, or risky security. Again, I'm like risky security has a price of 1. And has 2 payoffs. Like so there are 2 states. It's state A. You have payoff of B plus 1. It's state B. You have payoff of 0. And then security 2, which is also called risk-free security, risk-free, has a price of 1. There are 2 states. Under state 1, you're still gonna have 1 because it says that it pays 0%, and they did not mention any dividend, so it pays you nothing. So you gain no interest from your investment. So that's why the investment is gonna remain the same, 1. So they say that the utility function is gonna be equals to the square root of x. So we know that in our function we also have the first derivative, so we can just write it down right now, so that we don't forget. So this is gonna be 1. It's gonna be 1 over the square root. The square root of x. And then another thing that we have to take into consideration is that the wealth of this individual is going to be equals to 1 as well. So before we can start solving, we need to find your x's. So your x star, right? This is what you want now, your x star, right? So x star is the state payout, right? Is the state payout. So is the payout. So this so you have 2 assets and 2 states. Now when you buy these 2 assets, only one state will happen. You will either have this state, either this will happen or this will happen, but never both. So this is like this. So this is state A, and then state B. Okay, so under state A, if state A happen, the payout will be this. So it's going to be the sum of what? The sum of the thetas I times the payout, right? So for state A, so so this will depend on the amount of share you the amount of security of I of 1. So the payout for this one is going to be B plus 1, right? And then the amount of security 2 you buy, and the payout for this one is going to be 1 because it's only 1 over here, and then over here is going to be B plus 1. So if stage 2 happen, if state B happen, the same thing apply. If you have bought theta 1 security, the payout is going to be 0. And then if you have bought theta 2, the payout is going to be this. This can be simplified into what? Into just theta 2, right? So now you can start answering these 2 questions. You can start solving for these questions to find your thetas. So I'm going to start with this one. I'm gonna start with this one. So we say that the sum of the amount of prices, something like of securities times the prices, is gonna be equals to your wealth. So your wealth is gonna be equals to 1. So you have theta 1 for state 1, and the price for 1 is gonna be what? Again, and for security 1 is gonna be 1. They set the price as 1, and then the amount of security 2 times the price of security 2, which they said is also 1, it's gonna be equals to your wealth. Your wealth is gonna be 1, right? So basically I can just remove this ones over here. So you have theta 1 plus theta 2 is equals to 1, and then I can try to simplify this thing very well. So I can say that let theta 1 be equals to theta, right? So if this is the case, theta 2 from here, you'll have 1 minus theta 1, right, from here. So this simply mean that 1 minus theta from here. So theta 1 is going to be theta, and then theta 2 is going to be 1 minus theta, right? I just tried to simplify it, and then I can go to the next question, which is this one over here. So I can put it here, where they say you are trying to find the expectation of the first derivative of x payout equals to lambda times the price of security I for all of i's. So we have two states. So you have state A and state B, and state A has probability of 0.5 and state B has probability of 0.5. They say that they have equal probability. So to answer this question, this is what you will do. So your utility function is going to be 1 over, it's going to be 1 over what? It's going to be 1 over x. 1 over the square root of x. So you can write this. So this can be written like this. It can be written like this. It can be written like 1 over the square root of x squared. The square root of x times the payout per state the payout for states times the probability for state A. So I can say that this is the payout for state A, plus 1 over square root of x squared. Hexta the payout under state B times the probability of state B is going to be equals to lambda the price times the price of security I. So how do you find this? So you will say 1 over. So I'm going to find the answer for security 1. So for security 1, I'm going to have 1 over. So x for state 1, we say that x for state 1 is going to be this answer over here. You can say theta 1 b plus 1 over theta 2 times 1. the payout for this state is going to be b plus 1, and the probability is going to be 0.5 plus again 1 over the square root of the payout for this one is going to be what? It's going to be theta 2. So you'll have theta 2. The payout is going to be 0 times 0.5 equals to lambda, and the price for security one is going to be 1. So this whole thing over here is going to be 0. So there is no need to write it down. Again, we have already said that theta 1 is going to be equals to theta, and then theta 2 is going to be equals to 1 minus theta. So we can try to like simplify these things over here. We can simplify them. We can say that theta 1, we can say theta b plus 1 plus 1 minus theta, and then the answer is going to be what? The answer is going to be theta b minus 1, and then we have what? We have actually he's just going to be b plus 1, and then for this one you're just going to have 1 minus beta, 1 minus beta. So this are the state pricing after we have after we have simplified them. So we can take them back. So b beta plus 1. So you can just write this thing as b beta plus 1. So I can just say b theta plus 1. And then for security 2, again you are going to have 1 over beta, again b times theta plus 1 for state 1, and the payout for this one is going to be 1, because we say that the payout for like state 1 is going to be 1 times the probability times 1 over again, so theta 2, we say that theta 2 is going to be what? It's going to be 1 minus theta times the payout, again is going to be 1 times the probability of the state 2 is going to be 0, again is 0.5 equals to lambda times the price, and the price we said that is going to be 1 again. And then we will try to solve for theta in this equation. So so do you want me to solve for theta, or is it fine if I stop here? You can solve it on your own. And then how is everyone else? Do you have any questions, or do you want one more example? Okay, I'm not sure if everyone else understand, but then if you have any question, you can tell me, or you can text me. I forgot which way, again I forgot which past paper it comes from, but then I can send you the question papers from 2011 to 2019. I think I've up to 2019. I can send them to the group, if that's fine. Okay, I was gonna do one more example. If someone says they want help, I'm like, they still don't understand, I can still do one more example. If you have any question, please let me know, because my point here is to help you understand. Okay, I assume I can skip this question, so we can go to linear pricing. So linear pricing says that every price can be expressed as a linear combination of the state price in its elementary states, right? So how do we write this? Like we say that every price can be expressed as a linear combination of what? This is the payoffs and the state price. This is what we call the state price. So this is your state prices, right? So basically this is what this formula states. I'm like, oh, this theorem says, it says that every price can be expressed as a linear linear combination of the state prices. So there is not much in terms of understanding this. The only question which can arise from here is to derive this thing. So how do we derive this thing? Okay, before we can go to those things, I need to do one example, right? So you have three assets. A, B, and C. Each one of them has price 100, 90, and 95, and these are the payoffs. So these are the payoffs over here. So basically you have A. So A has price of 100, and that's three states. If state 1 happen, you have 200. If state 2 happen, 110. State 3 happen, 50. And then for B, the price is 90. 3 states. If state 1 happen, you have 100. If state 2 happen, you have 100. If state 3 happen, you have 60. And then again you have C, 75. If C happens, I'm like, if state 1 happen, you'll have 75 and 75 and 75. So the question says that calculate the state pricing. So they want you to find the state pricing, right? So we say that prices is going to be equals to the sum of the payoffs times the state pricing. So this simply means that to find this thing, this is what they are asking for each state. You have 3 states. You are going to find the state pricing for like each state, right? So in order to so if your state pricing are unique, it simply means that there will be no arbitrage, especially because this is a complete market. It's a complete market because there are 3 assets and 3 states. So if they gave you 2 assets and 2 states, it will still be a complete market. And then if they give you 4 assets and 4 states, it's a complete market. If they gave you 5 assets and 5 states, it's a complete market. So now you have 3 assets and 3 states. So this is a complete market. So to find the state pricing, the price is gonna be 100.
Sorry to develop.
Yes, yeah.
When you mean by complete market,
yeah,
you mean there's state prices for every asset, or like, do you mind explaining that part a bit?
Oh yeah. So when I say a complete market, I just mean like you have 3 assets and 3 states, or 4 assets and 4 states, or like 2 assets and 4 states. So in terms of the state pricing, this simply mean that the state pricing are going to be unique. They are not going to be changing. So so you are basically going to find one answer for every state pricing. So your answer, okay, let's say maybe your answer will not be infinity, or your answer will not be handy find or anything, or maybe you will not find one state having 2 different, so you will not have you will not find a state which has 2 different state pricing. So the state pricing will be unique. So this is what they mean by a complete market. So each state will have its own, so each state will have its own state price.
Okay, cool. Thanks.
Yeah.
Thanks so much.
So because you are going to have like the 3 so you are going to have 3 variables and 3 equations. So you are going to find a unique solution for each state. So to find the state pricing, you will have 100 equals to the payoffs 200 for state 1, 100 for state 2, 75 for state 3, and then asset number 2. Oh, sorry, I think I made a mistake. This is supposed to be 110. This is supposed to be 50. And then for asset number 2, the price is 90. 100 times the state pricing 1, 100 state pricing 2, 60 state pricing 3, and then again you have 75 with state pricing 1, 75 state pricing 2, 75 state pricing 3. So when you solve each of the state pricing, you are going to find a unique solution, and those answers you will find for theta 1, theta 2, and theta 3. This is what they are asking. This is what they mean by the state pricing. So this can be like 3 marks. So we can go back to our thing there. So it says that every price can be expressed as a linear combination of the state pricing, right? Where does this function come from? Because every other equation that we do, we always show where it comes from. So it comes from so it comes from up there. So up there we say that lambda prices is going to be equals to it's going to be equals to what? It's going to be equals to the sum. So the expectation of the utility of X times the payout, right? Yes, and then the P. So you can make P the subject of the formula. So you'll have 1 over lambda equals to what? Equals to the expectation of the utility star, right? And then you can take your lambda inside. You will have the expectation of, sorry, this is the first derivative, over lambda times P. So if this thing it's continuous, again, we know that you are going to have something like this, right? And then you will have this multiply by f of x, multiply by what? Yeah, but then now we are, again, now in this course, we are actually in this course, most of the time we will be looking at continuous, actually we will be looking at discrete variables. So we can write this as the sum the expectation is the sum, right? It's going to be the sum of the first derivative of this. I can put the d here, so the d, so this will be in terms of states, so s over lambda, lambda is a constant times the probability for each state. Then we can write this like this, so it's going to be the sum of ds times theta s, where I mean like phi, where psi s is basically the first derivative of x star over lambda times ps. So this is where that formula comes from. So this is what they mean by the state pricing. So this is where this formula comes from. So if they ask you, they again, so this thing can be like 3 marks if they ask you. So you should know how to like find this equation. So anyway, now we know that P can be expressed in this way. Prices can be expressed as a linear combination of the state pricing. We can let size 0.
Sorry, Javila?
Yes, yeah.
You mentioned they only ask us the discrete case, but then I just want to know what part of the function is continuous. Is it the price that makes it continuous?
Is your discrete? Okay, so for discrete, your utility function is discrete. I am not sure if that's what you are asking.
Oh, all right. Okay.
Yes.
Okay. Yeah. Oh, okay. I think that makes sense.
Yeah.
Yeah. Thank you.
Sure. Sure. So theta 0. So you can just say let theta 0 be equals to the sum of all. I'm going to use s because I used s over here. So you can say s the sum of all your, okay, I'm like all your state pricing. So if this is, yeah, so if this is the case, you can define a new thing. So you can define artificial probability. Qs is going to be equals to psi s over psi 0. This is what you call artificial probability. So if a question asks you to find artificial probability, you basically have to sum your state pricings. You basically have to sum them and then find this again, and then use this equation over here. It's gonna be size 0. Now size 0. So this is, so basically this describe artificial probability. So this is all they are asking you, right? So again, we can take this thing back to the equation. Our equation over here says that P is going to be equals to the sum of the payout times the state pricing, right, for all the states. So this equation again, so this equation over here, we can like simplify it. We can write it like this. We can say that this is going to be equals to Qs times psi 0, right? We have simplified it. So you can write prices as the sum of the payout times psi s. Psi s is going to be equals to Qs times psi 0, right, for all the state. So this is a new way of expressing your prices. So this can also be a proof. They can ask you to move from here to here. If that's the case, this is where your proof will end. But then you can also simplify it further, right? You can simplify it further. You can say that you can just take out this thing. It's a constant. It's not a random variable. You can take it outside. So you can see that size 0 is going to be equals to the payout times the artificial probability, right? So when you look at this thing, this thing looks like the definition of expected value, right? We say that expectation of something, right, is gonna be the sum of xi times the probability of I, and we already know that q is the probability. So we can basically say size 0, the sum of, actually not sum, we can just replace the sum as the expectation. So that's going to be the expectation of the payout, again using q as your probability. So where q is your probability, because q, again, we already know that q is a probability, so we can express this as a as an expected value. Again, so there is something about payout, like there's here elementary state, right? Every elementary state has a payout of 1, right? But then this thing is the sum of all the states, meaning that every elementary state has a payout of 1 1 1 1 1, right? So if you have 3 states, then you have payouts 1 1 1 1, so 1 1 and 1. So we can therefore express this thing as so we can actually express this thing as the total return of risk-free rate, of a risk-free asset. So you can write this thing like this. So you can say EQ times T. So this is what they can also ask you again, to prove. So this proof is actually common. If the lecturer wants you to prove, he can ask you to prove this question. So this chapter has many proofs. Yeah, this is it actually. So I'm gonna do a few questions. So this question here says that find the artificial probabilities. So to do that, we need to find the state pricing. So do you guys want me to find the state pricing, or should I move on? And then everyone else, Roof, Aviwe, are you guys also fine? Okay, so we need to find the state pricing. So we will have to solve this thing over here. So because it's too long, I can reduce it into a matrix. I can write it in terms of matrix form. So 200, 110, 50, 100, 100, 60, 75, 75, 75, 100, 100, 90, and 75. And then you can start to reduce this thing. you guys have an app which can like solve this very fast? I don't think I solved it in my code actually. No. Okay, so for 1 we see that row 2 minus 100, so row 2 minus 100 over 200 row 1, row 3 minus 75 over 200 row 1, so you still have 200, 110, 50, 50. So you will have 0 100 minus 100 over 200 times 150 times 110, you'll have 45, you'll have 60, 35, 40, 'Gonna be 135 over 4, 225 over 4, 75 over 2, and then you go further, see 200 again, 50, 0, 45, 35, 40. So row 3 you're gonna say minus minus what? Minus 134 over 4 times over 45 row 2. Then you'll have 0. So you have just making sure 135, this is 5, 135 over 4 over 45 times 45, so yeah, it is 0. You're gonna have 30, and then you have 40, let's say 75 over 2, then you'll have 15 over 2. So this simply means that for state 3 you have 30, 15 over 2. So this simply means that state 3 is gonna be how much? It's gonna be 210, right? So you have 210 over there, and then for state 2 you have 40 minus 35, 210. Over 45, and then for 2 you have how much? You have negative negative 146 over 142 over 2. And then for 3, wait, okay, yeah, and then for this one you will have 7,001 over 20. So this are your state pricing. I think again you you can go try them on your own and see if I didn't make a mistake somewhere. But then these are the answers I get. So to find artificial probability, you are going to say let psi 0 equals to the sum of all the states, right? So this will mean 7,000 over 2, over 20, plus negative 1462 over 2 plus 120, and the answer is going to be negative 170, right? 170,95. And then to find artificial probability of state 1, so these are the artificial probabilities. So you will have 700 1 over 20 over negative 170 over 95, and then you find your answer, and then you do the same for 2. For this one, for the so these things are called artificial probabilities. Artificial probabilities. So for 2, the answer is going to be negative 1462 over 2 over negative 170,95, and then you also find the answer, and then you do the same for 3 as well. So so those answers you find, they will sum to 1. Q1, Q2, and Q3, they will all sum to 1. So for 3, it's going to be 210. It's going to be 210 over negative 170,95. The answer I get now are not the same as the answer I got earlier. So I think I made a mistake somewhere in my calculation up here. I think I made a mistake somewhere up here. But then these answers are not the same as the answers I got earlier. But then, okay, so okay. I will read again. I will read this again. I will redo this thing, and then again, and then send it to the group. But then this is how you do these calculations actually. So I'm gonna do one more example, but then this one comes from an exam paper. It says that consider the situation where there are 2 security with prices and payout given in the table. So these are the prices, these are your prices, these are your payouts, and the payouts will depend on the state. So this is how it is. For A, you have price of 5 and 2 payouts. So you have 7 and 4. And then for B, again, you have same thing, 4, price of 4, and the payout is going to be 5 and 5. So you can see B hits a risk-free rate with 20% returns. Again, I'm like with 20% rate of return. So state 1, so you have 2 states, state 1, state 2, state 1, state 2. The question says that the probability of state 1, so the probability of state 1 is going to be what? It's going to be 2 over 5. So this simply means that the probability of state 2 is going to be what? It's going to be 3 over 5. Because it's a probability, so they should both add to 1. And then they say that consider another security C, which has which has payout of 5 and 4 in each state. So okay. So we don't know the price for C, but then they say that the payout is going to be 5 and 4, right? So a question says that explain how you know that C will be a linear combination of A and B. So it will be a linear combination of A and B because this is a complete market. So if it's a if this thing hits a complete market, then you are going to have C is going to be a linear combination of A and B. So, but then I am not very much concerned about this one. I am concerned about this question over here. So this question says that calculate the risk neutral probability. So this is what I'm like, this is something. Okay, so this is what she asked earlier on. So I think this one is simpler to find because you only have 2 assets. So before we can find risk neutral probabilities, we need to find the state pricing, right? We know that prices equals to the sum of the state payout times the state pricing, right? So the price for the first one is going to be how much? It's going to be 5, and then the payout is going to be 7 for state 1, and then 4 for state 2, and then the other one cost 4, and the price is going to be 5 for state 1, like the payout, and then the payout is going to be 5 again for state 2. And then you basically find these things. You basically find these things over here. So how do you solve for them? So you basically have one. You have 7, 4, 5, 5, 5, 4. So how do you solve your matrix? So R2 is going to be minus 5 over 7 R1. 7, 4, 5. 5 minus 5 over 7 times 7. You can have 0. 4, 15 over 7. Then you'll have 3 over 7. So this one you can see is much easier to find, and therefore the state pricing of 2 is going to be what? It's going to be 3 over 7. I'm like 3 over 15, sorry. It's going to be 3 over 15. And then the state pricing of 2, I'm like of 1, is going to be what? You will have 5. And then it's going to be 3 over 5. So these are your state pricing, right? And then now the question says here that find the risk neutral probability. So risk neutral probability is basically again, risk neutral probability is basically artificial probabilities. So to find them, you sum your state pricing, right? You sum them. You have 3 over 15 plus 3 over 5, and the answer for this it's going to be 4 over 5. So your artificial probability Q1 is going to be what? It's going to be 3 over 5 over 4 over 5. The answer is going to be 3 over 5. I mean 3 over 4. And the artificial probability for state 2 it's going to be what? It's going to be obviously 1 over 4. So this answer should match. So let's say 3 over 15 over 4 over 5. So it's 1 over 4. So, and both of them sum to 1. The sum of the states, I mean like of the artificial probabilities is equals to 1. So this again, so this is the artificial probabilities or the risk neutral probability that they are asking over here. So, and then this question goes further. It says that find the fair price of C. Find the fair price of C. So we say that C has payout of 5 and 4, right? So to find the fair price of C, the price of C, right? Again, you're gonna have the so we say that again, that theorem say that prices is gonna be equals to the sum of the payout times the state pricing, right? So what is the state pricing? Okay, the payout is 5 for state 1 and 4 for state 2. This look like psi. I'm gonna put 4. So we already know what psi 1 and psi 2. Okay, this thing is jumped. Okay, so for psi 1 is how much? It's gonna be 3 over 5, and then for psi 2 it's gonna be 3 over 15. So to find the price psi 1, you will have 3 over 5 plus 4 times 3 over 15. So the price for this one is going to be how much? It's going to be 3 it's going to be 19 over 5 or 3,3. So this is going to be the fair price, because in order to in order to like prevent an arbitrage opportunity, the price for this asset should be equal to the state pricing. So we know that the payout is 5 and 4 in the state pricing based on the answer we have found up there. Based on these answers here, where are they? Based on these answers over here, then this price should actually be 3,3. If the price is not 3,3, then it simply means that there is an arbitrage opportunity, and if there is an arbitrage opportunity, then you will be able to like exploit it. So yeah, any questions?
Sorry, Tabella, can you please explain that last part again about the arbitrage?
Yeah, so here we are looking at the state prices, right? So because this thing it's a complete market, né? So it simply means that the state pricing we find going to be unique. So in those state pricing we found is 3/5 and also 3/15. Now when we put these things, like the answer gives us 3,5. I mean like the answer is 3,3, né? But then if they have explicitly stated that if they have stated that the price of security C, let's say maybe they say that the price is 5, so it simply means that there is an arbitrage, because the fair price, this is a fair price, because the fair price of asset C is 3,3, not 5. So if we say that the price is 5, then there is an arbitrage opportunity. So you can try to find a way to like exploit this opportunity of the foreign prices.
Okay, cool. So they wouldn't ask us anything about like what is the arbitrage amount or something like that, right? They won't ask further than that. It'll stop by calculating the price.
Yeah. So your answer. Okay. Yeah. So your answer will end here. But then if they do ask you for this, ne, so what you will do, ne, you're gonna short sell this one. You can short sell this one if they ask you. So you are going to short sell this one. You are going to short sell this one, and then when you short sell this thing, it simply means that you will have 5 rand in your pocket, and then you're gonna take out 3,3 to buy asset again. So again, and then you will take out 3,3 to buy this one. They have the same payout, right? And then you will be left with this money. So you'll be left with how much? You'll be left with 1,7. So you have basically made 1,7 from not using your money, by just taking advantage of this opportunity. So something like this should not happen, because it can be exploited. So that is why in this course we are trying to find whether there is an arbitrage opportunity, or we are trying to find a fair price we should pay for a security based on its payouts or based on its risk.
Oh, okay. Okay, now that makes sense. Yeah. Is it possible to say that this is like related to the APT, arbitrage pricing?
Yes.
Model.
Yes.
So that if they say like, so that eventually the prices will reach the equilibrium point.
Yes.
After having arbitrage.
Yeah. So while you are busy short selling and other people are taking advantage of this, advantage of this opportunity, these prices will try to like go back to normal again. Until
to reach that fair price of 3.3.
Yes.
Which is the equilibrium price.
Yes.
Oh, okay. That makes sense. Yeah. Thank you.
No problem. And Avi, are you fine as well? It seems like there's only 3 of us left. And also, if you have any questions, you can, and you are shy to ask in the group, you can text me personally. I can wake up and answer your question anytime. So
sorry, is it time for one more question? Or you?
Yeah, you can ask any question.
This is like the last one. You know the elementary state prices, right?
Elementary state pricing.
Prices. Yeah. That definition. He didn't like explain it clearly in the lectures.
Yeah.
Do you mind like going over through that, like just briefly, if you have time?
Okay.
Exactly how to visualize it. If you just draw like a tree diagram, you know the thing that you did previously.
Again, like this.
Yeah, like that. But like just for the elementary state prices, like how would it look like?
For the elementary state pricing, it's just that I don't have the notes here with me, but then
because you said it was like 111.
Oh yes, yes. So
how is that?
Again, yeah. So by the definition, so when you have when you have an asset, under its under its under its elementary state pricing, so under its elementary state, so for like each state, so let's say this is the payout for payout phase, so payoff for state S. So this thing says that the payout for this asset under the state S, you are simply going to have what? So so the payout is going to be 0, 0, 0 up to S. Like actually this one is going to be 1. So this is your state S, right? I will show you now up to like going wherever. So if you have an asset in its elementary state, so it simply means that the payout, right? So let's say maybe this is for state 2, right? So you have state 1, state 1, state 2, state 3. The other state will have payout of 0, but state 2 will have payout of 1. And then for 3, let's say 3. For 3, the payout will be 1 but 0 for other state. So the payout under elementary states, it's gonna be 1. It's not gonna be any other number, but it's just gonna be 1. Only 1. I can actually, you can send me the notes because I can't find them, and then I can explain it to you further.
Okay, cool. No, I get what you're saying now. Yeah, so the E2 is a state. It's a state on its own, isn't it? It's not a price or anything. Like.
Yeah.
You get what I'm saying?
Yes.
Because like the previous diagrams that you drew.
Yeah.
You had the P there and then
yes.
different states.
Yeah.
But here,
yeah.
But here now, that E2 means a state and not necessarily a price.
Yes.
So then, when you went and further said, just that the last 2 lines of the proof, I think it was the expected value.
I'm gonna go back.
D. Do you remember you wrote? I think just before this question.
Here.
Yeah, exactly. That's right. So how does that translate to those last 2 lines?
Yeah, so actually in my thinking, actually, like this proof still doesn't like make sense, because if I were to again, I'm like, if I were to write this, I would say RF times EQD, but then I still don't understand why they had to find the inverse in this case. I'm not sure if this is what you are asking me.
Oh, I was also like, because I think the part that was confusing me was the EQD.
Oh.
Just that expression, right? You said it previously, but I couldn't quite catch on.
Oh, this one of. So this one.
Yeah, that's right. Because you mentioned something about the elementary state prices.
Oh no.
Being 111 and then.
Oh no, I was mentioning that for this one.
Right.
Again, so for the EQD is basically the expected value. So you can just say this is the so when you I'm like, when you look at this thing over here, so we say that the expectation of x is going to be equals to the sum of x times its probability, right? So you can say this thing is in terms of p, like is the probability. So we know that these Q's over here, these Q's, they are also probabilities. Although they have a special name, you call them artificial probabilities, but they are still called probabilities. So by definition, this whole thing can be translated like this.
Right. Using the equilibrium states. Oh, sorry, wait, the elementary states. Right? Something like that.
No. Just yeah. So this is just definition of So this is just the definition of expectation.
Okay. Oh wait, yeah, never mind, because those are the QS are the probabilities.
Yeah.
And that'll be for each DS.
Yeah.
Okay.
Yeah. Yeah. So you can just basically take out this Q if it's confusing you, or you can write.
It makes sense now.
Oh yeah.
Because I'm trying to translate the expectation to that. Okay, no, that makes sense.
Yeah.
Yeah.
Or you can just write, or you can just write this this thing as P, so that it doesn't confuse you. But then they use Q in this course, but you can write it. You can write it as P, and then state that it's P.
Okay. No, that's chilling. It's okay.
Yeah.
I just wanna. Yeah, I just wanna read something quickly. It's just like 2 lines, right?
Okay. Yeah.
On the textbook. It's on the textbook of page 251. If you have the textbook with you.
I don't have a textbook. 251.
Yeah. Okay, I'll read it to you then.
Okay.
It's quick, like 2 lines. You know that phi 0, that symbol?
Psi 0, yeah.
It says here, there's another interpretation. It can be considered as the price of the security, and then you know the vector 1 1 ... comma 1.
Which, how do I write vector again? Lambda or?
So it's the price of the security, and then they have a vector.
I'm not
vector.
Sure.
Yeah.
Yeah. 1,
comma
1,
and another 1.
Yeah.
Yeah, 1, like that.
Yes.
That pays 1 in every state.
Yes, that's true.
In other words, a risk-free bond.
Yes.
Good, because I don't know what they mean by that. Like,
yeah. So. Yeah. So this one goes back. Okay. So each asset at every state in its elementary state has a payout of 1. So when you are looking at state 1, so he simply mean that under its elementary state, it will have a payout of 1, 0,00 up to 0, and then when you have this one 2, you will have 0, 1, 0 up to 0 there. And then now we have said that size 0 is the sum of all.
Oh,
yes.
Right. So sum of all those vectors.
Yeah, so they will have 1, 1, 1, 1 in all the states.
Okay, right. Okay, that makes sense. Yeah. So you could think of each what's it called, that phi 1, that state price, as a vector which consists of
payout
a series of payoffs.
Yeah, of 1.
Okay.
Yeah, so under this concept of elementary states, we only talk of payouts as 1. So the payout is gonna be 1.
Right. Okay. Cool. Yeah, that makes sense.
Yeah,
that makes sense. Thank you so much, though.
No
Sorry
problem.
about the time.
No problem. And then why is your friend not attending? Lando.
Oh, I don't know. I think he bounced earlier. Well, wait, I don't know if he was here also.
Yeah.
Maybe he had to do something, probably. I'm not too sure. I'll check out with him what
okay.
happened.
No problem.
This year. But the session was helpful. Like, it cleared out a lot of misconceptions.
Yeah.
So,
no problem though.
But yeah, thanks so much.
No problem. And we are still good. Abiwene. Yeah, if you have any question also, you can text me personally. I can answer your question. And also I can still make a video, like I can make a private video, and then post it on the channel, and then you can watch it. Or we can have or we can have another session, like one-to-one session, if you're shy to ask, and then I can help you in there. So anyway, I'm gonna stop the session.
Sorry, Tabela, one more thing. The past papers, do you mind also forwarding that on the group?
Yes.
For us, just to practice it. Okay. Thank you. Thank you so much.